Good morning, students. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today's our topic is problems on exhaustive events and random probabilities. What are exhaustive events in probability? Actually, it will give the sample space, like just we will take the sample space 1, 2, 3, 4, 5, 6, and here we have to assume that A, B, C are the events which are associated with this experiment. Now let's define the events, like A, be the event getting number greater than 3, B, getting a number greater than 2 but less than 5, and C, be the getting a number less than 3. So these events we can write A is equal to 4, 5, 6, B 3, 4 and C 1, 2. Now we observe that A union B union C, that is 4, 5, 6 union 3, 4 union 1, 2. So after that you are getting the 1, 2, 3, 4, 5, 6, that is original sample space. Therefore we can say that A, B, C are exhaustive event. The probability of exhaustive event is always equal to 1. Now we will take one by one examples. First one is that in an experiment, 3 coins are tossed at the time, and consider the following events. The events are A, no tail appears, B, exactly 1 tail appears, C, at least 2 tails appear, and do they form a set of exhaustive events? Now solution is that in the experiment of tossing a coin 3 times or 3 coins tossed at the time, the outcomes will be the same. That is, the sample space constitutes the same outcomes in both the cases. Here your sample space is head, 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 tail, then head, tail, head, then tail, head, 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 tail, tail, then again tail, head, tail, 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 head, and 3 times tail. So as per given, your event A is that no tail appears. That means only heads will appear. No tail appear means only head will appear. That is A is equal to triple H. Now event B is saying that exactly 1 tail appears. Now you have to find out where only 1 tail is appear and see. This is your 1 tail, 1, 1. Exactly 1 tail we have to display. So here B we got. Then 2 tails and more than 2 tails can be considered. So C event is that at least 2 tails appear. 2 tails or more than 2 tails. So here HTT, HT, TTH and TTT. Now what we will do? We will union this event A, event B and event C. After that you are getting the same sample space, which is the original value, original set of the sample space. Therefore these A, B, C are exhaustive events. Now second one is that consider the set of first 10 natural number and check the following defined events are exhaustive. First, selecting a prime number, B, selecting a multiple of 2, and C, choosing a perfect square number. Now solution is that sample space, set of first 10 natural number. Sample space is that set of 10 natural number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, these numbers will be in your set. Now A is event of selecting a prime number. Only you have to select the prime number. So 2, 3, 5, 7, these are your prime numbers. And B is the event of selecting a multiple of 2. 2, 4, 6, 8, 10. These are the multiple of 2. And C is the event choosing the perfect square number. From here we have to find out the perfect square number, that are 1, 4, 9. So now again Event A, B, C, we will use the union, and after that you are getting the original sample space. That's why this given set of the events are exhaustive. Now example 3 is that given an experiment of tossing a coin. Let A be the event getting head or tail. Check if A is an exhaustive event. Also determine its probability. Now solution is that we know that only possible outcomes when a coin is tossed are head and tail. This implies whenever a coin is tossed, either head or tail will be the outcome. Hence, A will occur definitely. Now, event A itself is the sample space, and hence A is exhaustive event and it will occur whenever the experiment will be performed. Now, probability of event A is a 1, and so A is an exhaustive event, so probability of A is 1. Now, example 4. Consider the sample space S and 3 events A, B, C. For each of the following events, draw Venn diagram representation as well as set expression. A is saying that among ABC, only A occurs. At least one of the events A, B or C occurs. Then A or C occurs but not B. And at most 2 of the events A, B or C occurs. Among A, B, C, only A occurs. That means A minus B minus C. And here A minus B union C. Then second is that at least one of the events A, B or C. So we can take A union B union C. A also can occur, or B or C, or we can say all events will occur. So A or C occur but not B. A union C but not B, so we will subtract the B. At most 2 of the events A, B or C. Maximum only 2 events we want. So what we will take? Combination of A intersection B intersection C. That is, we will do separate, and then it will convert into the union A union B union C. So you can say that, check that A is A minus B union C. This diagram is showing A minus B minus C. Then A union B union C. A union C minus B. And A intersection B intersection C. So this portion will display. Here this portion will display. After that here this portion. Now next example is that write a sample space S for the following experiment. We toss a coin until we see 2 consecutive tails. We record the total number of coin tosses. A bag contains 4 balls. One is red, one is blue, one is white and one is green. And we choose 2 distinct balls and record their color in order. Customer arrives at a bank and waits in the line. We observe T, which is the total time, and that the customer waits in the line. The bank has a strict policy that no customer waits more than 20 minutes under any circumstances. Now here solution is that, here you have to remember that sample space is the set of possible outcomes. Usually, when you have a random experiment, there are different ways to define the sample space depending on what you observed as an outcome. So in this problem, for each experiment, it is stated that what outcomes we observe in order to help you write down the sample space S. Now we toss the coin until we see 2 consecutive tails. We record the total number of coin tosses. Here the total number of coin tosses is the natural number larger than or equal to 2. So sample space is S, 2, 3, 4. Now second one is a bag contains 4 balls. Now here one red, one blue, one white and one green. Now we choose 2 distinct balls and record their color in order. The sample space can be written as RB red blue, blue or red, red white, white red, red green, green red, then blue white, white blue, blue green, green blue, white green and green white. So here next one is that a customer arrives at the bank and waits in the line. We observe T. In theory, T can be real any number between 0 and 1 by 3 equal to 20 minutes. Thus, as there is a set 0 to 1 by 3, so X belong to R, 0 less than or equal to X less than or equal to 1 by 3. Now next question is that I roll a fair die twice and obtain 2 numbers, X1 and X2. X1 result of the first roll and X2 result of the second roll. So find the probability of the following events. A defined as X1 less than X2 and B defined as you observe a 6 at least once. As we saw before, the sample space S has 36 elements. We have A event. So these are the value of the A event. After that, we got the P of A is equal to magnitude of A divided by magnitude of S. So that are 15 divided by 36 and after simplifying you will get the 5 by 12. Then second one is that we have B. So B event values are, so B has a 11 and S value is 36. So P of B is probability of B is 11 by 36. Now example 7. A likelihood of the 3 teams A, B, C winning a football match are 1 by 3, 1 by 5 and 1 by 9 respectively. Now you have to find the probability that out of the 3 teams either team A or team B will win. Either team or team B or team C will win. Then none of the teams will win in the match. And neither team A nor team B will win in the match. Now P of A or B will win. That is 1 by 3 plus 1 by 5. It will come 8 by 15. Then probability of A or B or C will win. Again 1 by 3 plus 1 by 5 plus 1 by 9. That will be 29 by 45. Then probability none will win. So here 1 minus probability of A or B or C will win. That is 1 minus 29 by 45. This value already we got. So after solving 16 by 45. Then probability neither A nor B will win. So is equal to 1 minus probability either A or B will win. 1 minus 8 by 15. So it is 7 by 15. Now example 8. If P of X is equal to 1 by 3, P of Y is equal to 2 by 3 and examine whether X and Y are mutually exclusive and XY are exhaustive. This we have to prove. The events are said to be mutually exclusive if probability of X intersection Y is equal to 0 and the events are said to be exhaustive if probability of P X union Y is equal to 1. Now probability of X plus probability of Y is equal to 1 by 3 plus 2 by 3 and probability of X union Y is equal to probability of X plus probability of Y plus probability of X intersection Y, that is 1 is equal to 1 minus 1, 0. Actually this here should be 0 minus. So if probability of X union Y is the sample space, then above two conditions will be satisfied. And X, Y are mutually exclusive and exhaustive. Now example 9. Box containing 4 bulbs. Probability of having one defected bulb is 0.5 and the probability to have 0 defected bulb is 0.4. Now you have to calculate the probability of one defected bulb and 0 defected bulb. Probability of single bulb defected is P of X, that is 0.5. Probability of 0 bulb being defected is P of Y, that is 0.4. There can be either 0 defected bulb or 1 defected bulb because these two events cannot occur simultaneously. Hence, they are considered as mutually exclusive. X or Y is equal to 0.5 plus 0.4 is equal to 0.9. So, this is all about the probability problem solving on exhaustive events. These are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.